Hello, today we're going to learn about basic automation tasks. Basic automation tasks are the ones that use sensors and actuators to automate a simple task. First of all, let me remind us a little bit about the elements needed for automation. First of all, we have an input. As in every control loop or any control system, we need to take a signal from somewhere. This input is normally taken from sensors, but it can also be input coming from a user as a human machine interface. This input is taken into a control unit that has the proper automation rules to make decisions on what to do, what action to take, that leads to an output. This output makes the action, and the effector or actuator can be a motor or a light or any signal that comes outside from the control system. Many times we get feedback from this output in order to control input and to make a closed loop automation system. Let's take, for example, an automatic door control in a garage. An automatic garage door has a motor that can run forward or backward or upward or downward, and can have sensors in order to decide when to stop and the upward run or the downward run. So in this case, we want to automate the task in which, if the control button is pressed for security for a couple seconds, the door will open until it reaches the upper limit, and it will stay there for about 1.5 minutes, and then drop back down until it's fully closed. So for this, let us consider that we have our controller properly tagged, in which the motor has the open motor function and the closed motor function. This is the tag I am using. It could be any. We have an upper limit sensor that is called up limit, and the lower limit sensor, which is low limit. Alright, so let's analyze the first network. This would be an example. The open button that is wired into this input 0.0 activates a timer on delay for 2 seconds. This means that it needs a pulse time of 2 seconds. Let's say this is a security function, and would eventually turn on the open motor. And I'm using here a normally closed, a not negated gate for the up limit sensor. When the up limit sensor is activated, as the door reaches the up position, it's going to cut the flow here, and the open motor will stop. Notice that I'm using the open motor as a sensor, so that once the open action is activated, this action will continue to work constantly until the door opens. So this is a fully automated open function. Now, after that, as it opens, it is going to wait 1 minute and 30 seconds when the up limit sensor is activated. So this means that the door has been fully open, and start closing the motor. And at the same time, I'm using the same technique here. The low limit sensor will stop the whole system when it is activated. So that's why I'm using here a not sensor, a not contactor, and I'm using the closed motor coil as a contactor here in order to keep the action until this low limit sensor continues. Now, how may this automation task be improved? What potential faults exist? Think about it, and we'll discuss it soon. Good luck.